Okay, to solve an equation for a certain variable, we need to isolate this variable. So we have to look at what's being done to the variable in this equation. So we have e equals mc squared. The variable we're trying to isolate is m, so it's being multiplied by this. So we're going to divide by it on both sides of our equation to get e equals, or e over c squared equals m. And so now I've solved for m. In this equation, we want to solve for a. So to solve for a, I have to undo everything here. So the first thing is any adding or subtracting. So this subtraction of d needs to be added to the other side. So f plus d. Then the next thing is I have a c that I need to divide because it's being multiplied. That cancels it out. So now I have a plus b equals f plus d over c. And then the last thing is subtract b. So to isolate the a, I have my f plus d over c. And I'm going to subtract b because that's what I have to do to get rid of it in this equation. So on these problems, we're going to multiply, divide, add, and subtract. And when we're multiplying, you just multiply straight across. So 3 times a is 3a. 4 times 5 is 20. And that is our answer in multiplication. Division, we do what's called a keep, change, and we flip the second number, or fraction. And then we do exactly what we did in multiplication. We multiply the 7 times the 2 and the 3 times the a. And we get that answer. Addition, these two have to be exactly the same. In this case, they are, so they stay the same. And then all we do is add the numerators. Same with subtraction, they have to be the same. If they're not, we need to make them the same. In this case, they are already, so I keep them the same, and then I subtract. And I have my answer. All right, to do this problem, we need to substitute 5/8 into where x goes. So that's the first thing I'm going to do. And at the same time, I'm going to change this 2 to a fraction that I can add to the 5/8. Then on the other side, I do the same thing. And I'm also going to change these denominators to the common denominator, which happens to be 40. And when I do that, this becomes 25. This becomes 8. Now that I have all numbers, I can add the 5 and the 16, which gives me 21 over 8 times 1/5, which ends up being 21 over 40. And then when I subtract this problem, I get 17 over 40. And from this point, you should be able to tell that they're not going to be equal. And since they're not going to be equal, this is not a solution. All right, the first thing we need to do with this problem is we need to change this fraction. Mixed fractions are not good to use, into an improper. Now I can use this where I see the x. So I'm going to go 12 minus 3. And I'm going to substitute a 7/2. Now in this case, I'm also going to change my 2 to a mixed fraction. Then I substitute 7/2 where x is in the other equation. And once again, the 3 has to change, so it becomes 6 over 2. Now I have my substitution. I can go through and do the math. So I do inside the parentheses, this becomes 3/2, and that's going to get multiplied by 3. Then over here, this can be multiplied already. 28/2 minus 13/2. And so this becomes 15/2. And then over here, this is, I need to 12 minus 9/2. And by changing the 12, I should have 24 over 2 minus 9/2. I get 15/2. And it is the same number, so it is the solution.